It's a beautiful, beautiful morning in what? Strange. Oh, let's see. Oh wait, this should not be 12. This is gonna be too loud. So it is a beautiful morning, and I am blessed and lucky to be able to design this illuminator. I'm so happy I have all of today, just like yesterday, to just get something done. All right, so for context, what we are building is basically a printed circuit board that allows me to turn on these lights with a microcontroller. It also has one other additional bit of functionality if you decide to use a Raspberry. So there are two microcontroller. Well, one of them is not really a microcontroller. There are two computers that you can use to drive this board. The first is a Raspberry Pi. Now, the Raspberry Pi will basically use three of its GPIO pins. One is ground. Um, one is a signal for this MOSFET here. And then the third is not used. So it really only uses two signals, but we're using a TRS headphone jack connector. And all that's to say is basically, you write some code to turn on one of the GPIO pins on the Raspberry Pi, and these lights will turn on. And these lights are blue. And the reason why they're blue is because, one, I kind of didn't want to use UV LEDs, but if we go to FP base to the A Victoria, what is it called? A Victoria? Aquaria Victoria, which is the Latin name of the organism, and there was a gene extracted from this organism that if you shine these frequencies of light at it, it will emit a spectrum that looks like this. So basically, there's a protein that gets expressed, and that protein has what's called a fluorophore or a chromophore in it, which basically has this cool property of emitting light at a specific frequency. And you can see that the peak of emission is actually pretty strong, while the absorption spectra is pretty diffuse. And so we could, and I was thinking it would probably be way better if we used these 395 things, but it adds a layer of safety concerns to use this, whereas targeting the second peak at 475 is a little bit more and I think it'll fluoresce fine enough as long as we use a long enough exposure. So, so these lights turn on. Then basically on top of this is going to be a diffuser, a piece of acrylic plastic that's 3 millimeters thick that will diffuse the light so that there's not sharp peaks. And then that diffuse light on top of that will be sitting a petri dish. And let's just look up a petri dish. Okay, and that on that will be basically newly transformed or back diluted, or basically a new streaking of cells with this GFP expression. And basically what we're going to do is then have a box that's very close to light and then a camera on top and do a time lapse. Now the second way that you can control this device is with a Raspberry Pi Pico. Now with the Raspberry Pi Pico, we actually do use all three signals here. So the first signal that we use is the ground. Then the second signal is the MOSFET. And then the third signal is going to be to control this optocoupler. And the reason why I used an optocoupler is because the name sounds cool. And the other reason I used, yeah, well, I don't know. I think I could have, wait, actually, wait, I don't think this is right. So, oh yeah, and then so the way that we designed this, so what we want to look for is we don't want that. Because then it's not, Then it's not isolated anymore. I think I need to delete this. I'm kind of I this is strange though. So okay, so basically uh okay, I need to do this just in case because every morning it seems like it might reset. Okay, it's fine. Okay. So this is TRS, but they don't really say what the pinout is. So presumably the way that this thing works is that the half press shorts to okay, wait, hold on. Let's just figure this out. Um this exposes the MCDC2 port as a 2.5 millimeter TRS connector. Also with a remote. What is likely the pinout of the TRS? Tip to shutter, ring to half to focus, and sleeve to ground. Oh yeah, so one thing that you know, I feel like this was in the back of my mind for since I started this project like 3 days ago, and basically, so I mean, the thing that we need to find what part is this. I don't know if it's just Firefox, but I swear ChatGPT is so slow. Pin 1 is sleeve, right? Pin... Wait. Wait, I feel like pin 4 is the tip. Wait. I think I have it switched. And I never tested that on my... Okay, I think... Okay, so the to-do list is, every morning, the thing is you go down this rabbit hole, this total rabbit hole of like... Okay, so, pin 1 is the sleeve, pin 2 is the sleeve, pin 3 is the tip. That doesn't make sense to me. I feel like that's not right. That's the thing about these Chinese data sheets, man, is that... I don't know. Wait, actually, hold on. What does that mean? Is this a pinout? I feel like that might be a pinout. Never noticed that. Bro, why is it correcting me? I said obviously this is, it's like it doesn't actually understand what I said. The it comes in from the left. So then the 4 is the tip. Okay, I think we're gonna have to test this with okay, so wait. So what we need to do is the first thing we're gonna test the halt or test the clock out using using the headphone jack, the 3.5 to. So we're gonna look at the clock2.kicad and verify this because we have these things. Actually, we don't even need to do that. We can just do a continuity test. Okay, let me ask this. Then I'm just gonna go get one of those headphone jacks, get a multimeter, and then we're just gonna test it because I don't want to get this wrong because it's kind of possible that I did get it wrong. But the thing is, we used the tip and sleeve for the same connection, so it doesn't actually matter. But yeah, I would assume that 3. Wait, this is a different symbol than. Wait. Wait, this is a different symbol. My guess is that this comes in from the right. What are they talking about, dude? This obviously comes in from the right. This is gonna come in from the right. Or sorry, no, wait. In this case, it's coming in from the left, and in this case, it's coming in from the right. But basically, it's coming in from there. So then 4 should be the tip. 4 should totally be the tip. All right, so we just need to go get a headphone cable that's cut open. I probably have so many TRS. I just need to go find them. Oh boy. It definitely comes in from the left, I agree. Bro, God. So stupid. Also, this is like a different, this is not even the same. All right, let's just go test it. This is dumb. All right, I'm gonna go get a headphone jack or and a headphone cable, and then we're gonna just figure this out. The issue is that this actually matters, so it's worth doing this. Because otherwise this opto... I mean, realistically, as long as the optocoupler triggers, we can... Okay, and actually this doesn't matter. This is kind of not important, but... Just get a headphone jack. Okay. Okay, so I'm gonna just draw it out. In case we have this, 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 and this. Okay, so now we want to plug in the headphone cable. And we want to figure out which pin is connected to the tip. So we're going to take this thing. And actually, I'm going to switch these out. I don't like these because, like, what I've been meaning to do is, like this one's okay, but this one's, like, super crummy. I need to go find another one of these because this one sucks. But I think this one's pretty good. The problem is this Anyway, I don't care. No skin off my back. Alright, let's do this. Okay. Continuity mode. Just check that it's working. Okay. So, alright. So we're going to attach this to the tip. Okay, wait. We do want the pin numbers. Well, I guess we don't really know what those are. Maybe we can just look at the footprint and see if they're numbered. Can I just, Okay, so the headphone jack is here. Now, update footprint, open in footprint editor. All right, so we just want to, okay, so pin 1 should be the sleeve. All right, so if this is pin 1, oh, this sucks, man. Because this thing is 2, okay. Maybe I'll use the red, whatever. Okay, so that is the sleeve. So now pin 2 is over here, and that's also the sleeve. So wait, hold on. What we also want to check is that 1 and 2 are still connected. So that's this whole thing about them disconnecting when you plug in something is a lie. That's not switched at all. So okay. Let me just write this down because this is hilarious. Like ChatGPT just didn't. So I do believe these pinouts. 1, 2, 3, 4, and 5. And so these, so 1 and 2 stay connected no matter what. And 1 is sleeve. All right. So now we're going to do pin 3. Now what we expected was pin 3 is the... Okay, pin 3 is the ring. Is that what it said? Ha! I knew it! Dumbasses, I knew it. I'm yelling at ChatGPT, but it's so dumb. It's like, I don't know. But yes, obviously from this diagram, pin 3 is the ring. Like, you're pushing this in through here, and this is further left. Like, that's obviously the ring. Okay, so 3 goes to ring. Now, pin Let's look at the footprint. Pin 5 is what? Pin 5 is the latched thing. So if we try to connect, and pin 5 is connected to the tip, which makes sense. So pin 5, if we try to connect pin 5 and pin 4, nothing happens. But if I take this out, okay, so 5 is connected to 4 switched. And then 4 is the tip by process of elimination. 4 is the tip. All right, cool. So I think, is that what we had in the code? If I go to PJ, where is it? Because I manually edited this. So the tip, the 3 is the ring, bro. Come on. So we're going to have to fix this. So some of the routing needs to be redone. Oh, yeah. Okay, well, I'm glad I did that, though, because I don't think it mattered for the clocked.pcb because I only had one signal to deal with anyways, but, you know, it's nice to know what's going on. Okay, good. So we can close this. We don't need this anymore. We can close this whole KiCad thing. All right. Oh boy, that was stressful, dude. The 3 goes to the ring. Yes. I mean, this diagram is so obviously that, and it was just trying to gaslight me. Okay. But was there not another concern? The other concern was that pin 4 no, because if we're shorting the sleeve and pin 3, no, we need to be shorting. So first off, we need to remove the connection on ground, which we did, and then we need to have 4, which is the tip, go to this. Wait, why is that? Wait. Oh, for some reason they wanted the sleeve side to go here. Okay. Okay, so this does need to go to the sleeve, and then this just needs to be exchanged because the funny thing is here, this actually, it does matter because then all we're gonna do is focus the camera and not actually capture a picture, which is not what we want. And adding another optocoupler to add both functionalities is dumb. So what we need to do is we need 4 to go to pin 4 of the optocoupler. And this makes sense that 4 is here because this is the tip and this is 3 is the ring. Bro, I mean, even the pinout. All right, I'm done talking about it, but that's clearly what's going on. Also, I'm going to remove this DRC requirement that these are connected together. So, okay, so we figured out the pinout. We did that. That's great, and we fixed it. Now we need to remove these like weird, move extraneous traces that DRC complains about. For locating holes. For the locating holes of these parts. Okay, so we don't want the ring to go here. We want the tip to go here. So back in main.atto, we want the tip to go to opto.4. Okay, so we should be able to rebuild this, but I'm kind of worried. Okay, wait, so let's save this. Found important bug. In headphone jack pinout. Committing before atto build, because I don't know what it's gonna do. Okay, so we just need to. How do you expand it again? Select, expand selection. Okay, good. So we just go delete this trace, and then we're gonna have to redo the fill zones, right? And then this delete. And then, okay, so then we need to actually do the trace width stuff. Actually figure out the correct way to do nets and trace width classes. Because I want to do this the right way. I don't want it to just seem right. I want it to, because the thing is, I want this to be right. If it's a logic level thing that's not sinking any current, why is the trace a millimeter thick? No reason. Okay, so I think what I actually want to do is delete this. Then I want to rotate this to maybe be like this. And then if we do this, I can't rotate this? What? Why can't I rotate this? Oh, when you're grabbing, dude, that's so insane. Okay, that seems good to me. So then this will go like this, and this will go like this, and this will go like this. And what that is this, wait, this is wrong too, because this is, because wait, did we write down the spec in the documentation? In README. The tip, so the tip right now is going to the FET. So we're gonna have to redo all of this. Oh yeah, see this, because that's all wrong. And then the ring is used by both. And that actually, these two can be, anything coming from signal like this can be, like these can be thin traces. Okay, this works out perfectly. And realistically, we could have connected two in one, but they're already connected. Okay. This is a pull down. It's weird that they don't give you the value. Like, or I guess, no, I guess they don't give you a value because, I don't know. They could, I think they could give you a value if they wanted. All right. I'm gonna have to move my computer. I feel pretty good about this right now. That we tested the headphone jack thing. Because that would have been so annoying to have to debug that with the chip here. Realistically, I don't think it would have actually mattered. I think we could have just fixed it on the software side. Did we do 5 volts on the top? Can we look at this fill plane? So this goes to VCC. So, like, you know, the thing about that is, like, yeah, this thing is not heating up. Heating up. Okay, I want to remove these, and I feel like what I'm going to do is just ignore the... I'm just going to ignore... Because, like, what is the point of that? Okay, so... All right, let's just trace the current path. So let's say the FET is on. Okay, then current is going to be flowing from the VCC through here into all of these resistors. And then it's going to flow out. What is the current out path? There's a via somewhere that I'm not seeing. Okay, so this is the main flow. Is like all of these go through and then they all sync through here. So this trace is going to have an amp going through it. And then it's going to go to this FET and it's on, so now it's going to go through this ground into here. So all of that seems fine to me. And then what is this? This is just a, oh, this is, okay, this is the big decoupling. Realistically, decoupling doesn't probably need a big trace like that. If I just click B, does it redo the fills? Okay, well that's nice that I can just update the fills after I... KiCad's not so bad. I hate on KiCad just because it's like... some things are easy and some things are hard, and it's hard to know what is easy and what's hard. I mean, more generally, it's like doing stuff that you would expect to see in CAD, like normal mechanical CAD, is hard. Like constraints, there's no constraints or anything. All right, so are we done with this board electrically? So when the tip goes high, the opto turns on, and then the camera takes a picture. Man, that'll be so cool to see working. I feel like once my cable comes today, I'm gonna want to just like demo that and try that out. Which presumably is coming today. All right. So, um, but you know what? This is the thing about layout though that drives me absolutely nuts. Is like, first off, where's the mounting holes? Oh, wait. Okay, wait. Hold on. Do a search to find how to declare mounting holes in Autopile. Because when I rebuild, the things go away. And we don't want that. Wait, let's go to the Autopile. See, that's the annoying thing is that LLMs can't even find this Discord. So, like, realistically, they should try to hook up that question and answering thing with Oh wow, that's very cool. I mean, these people build dope stuff. Like, let's not kid ourselves. I should probably learn to use these. Wait, what? Okay, this is a rabbit hole that I don't want. How do I change the theme here? Um, how do I change the theme, man? I wish they just had a system one that just synced to system, but I don't. Okay, so I wonder if I do this, is it gonna yell at me? Okay, it doesn't. So it doesn't yell at me, just because I have these. Because this doesn't do anything. Okay, but we do need to. Uh, I, I'm tr I'm trying to think about. I'm trying to think about how this is gonna work. Like CAD wise, because we're gonna do the mechanics soon, and we're gonna need cables always, bro. Cables are like the hardest part of this stuff. I can't see anything. Okay, whatever that is. Did that have mounting holes? No. Oh, this is actually one. Oh wait, no, this is from the 135. Yeah. Okay, good. Oh, this is actually a good diagram. C4 is clearly the tip. I don't know. Maybe I should have given it this picture. This picture is actually way more clear than this electrical script thing. Okay. Wait, where's the Discord? Okay, let's just start. Come on. I mean, come on. The CAD is the thing I'm procrastinating on. What is the thing that I'm procrastinating on? Let's just do that. Let's see what's new, though. CAD improvement query variables. I want to watch this video.
This release includes a powerful new parametric selection tool named Query Variable. It allows you to dynamically define what selections are used in downstream features. In this video, we'll look at a few basic examples. This board with pegs through it was defined with a few simple features. The design sketch contains all possible locations for the pegs, and the user has selected their desired locations within the extrude tool. A Boolean subtraction was used to create the cuts through the main board. And finally, a hole was placed through the center of each peg, once again based on a user selection from the design sketch, and an appropriately selected merge scope. The problem with design intent occurs when trying to add additional pegs. The user edits the extrude feature and adds the additional selections, but notice that neither the Boolean nor the hole feature are included in the new pegs. This is because the downstream features were defined based only on the parts that existed at the time they were created, so we'd need to edit those features and add the new parts to their scope. Instead, we'll now solve this using query variables. Rolling back above the extrude, we'll define a new query variable, which we'll name design. Query variables support a variety of options. In this case, we are simply picking selections for where we'd like the pegs defined. Notice that we pick both the face and the vertex for each selection. This will be important in a later step. We'll then edit our extrude feature, and rather than utilizing manual selections, we'll instead use that query variable as the input. Notice a peg is correctly extruded at each location we selected in the design query variable. We'll define one more query variable at this point, which I'll name pegs. Instead of using selections, I'll choose the selection type of created by, select extrude 1, and change the entity type to body. This query variable is now parametrically gathering all individual bodies that are created as a result of the extrude 1 feature.
Oh, that's so cool.
This is exactly the geometry that we will need to define as our tool bodies for our next Boolean operation.
That's awesome, man.
Finally, we'll update the hole feature. The merge scope will be our query variable defining the pegs. The locations will be the query variable for design. Notice that even though our query variable design contains both sketch faces and vertices, when applied in a dialog, the query variable automatically filters out any invalid selections, in this case passing along only the vertices to the feature itself.
Yeah, well that's makes
Our model
sense.
is now correctly defined using parametric selections through these query variables. Changing the design variable to include additional peg locations causes all downstream features to rebuild as we would hope, with no further cleanup required.
That's so sick.
This is just one basic example of how query variables can be used. Exploring them further, you'll find there are a large number of selection types available, and each selection type has different filters for entity type. The use cases for query variables are far-reaching, as you can even define additional queries within a single variable to further filter your selections. For more information, we strongly encourage you to review the help documentation.
Bro, that's so nice.
This release
I forget what derive is.
Document Notes puts project context where you work. Inside any document, click the Document Notes icon to open a panel on the left. Inside any document, this release of Onshape includes a significant enhancement for PCB Studio, the addition of a full board and component feature tree for imported ECAD data. Whether the design comes directly from Onshape or from an external ECAD system, the feature tree now shows the key elements of your board in a structured, easy-to-navigate way. What you see in the tree depends on the ECAD format. For IDF format files or PCBs modeled in Onshape, you'll see the board, components, component instances, and keep in out areas. For IDX files, the tree also expands to include the board's layers, layer stackups, and defined regions. This improvement makes it easier to review, organize, and manage complex PCB designs, providing greater clarity and consistency when working across mechanical and electrical teams. Onshape Cam Studio now makes it faster than ever to set up machining operations with new powerful selection tools. Imagine you're preparing a plate with hundreds of holes to be drilled. Instead of selecting each hole manually, you can now use progressive selection to quickly grab all blind or through holes in a part. From there, you can filter the selection even further, by diameter or depth, so only the holes that match your machining intent remain. This makes it easy to create toolpaths for large groups of similar features in just a few clicks.
Man. I haven't done a real CAD thing in a while. I did that Eurorack thing, but that was like junk. It wasn't junk. There was some good stuff in there, but this is gonna be real.
You would have seen.
Bro, bro, I'm subbing to this guy. All right. Okay, let's get on with it. Get on with it. All right, so here, document illuminator. All right, so, um, I think I do 5. I think I do 5. So there's 2 mil. Because the thing is, this board is not undergoing any mechanical stress, other than that of over tightening the bolts. Dude, that new framework 16 looks so good. Okay, 4. All right, so let's just try to... All right, so wait, here's what we need to do. This is how I start everything. I go create variable studio, and then I think I need to... We'll move that. We'll do that after. But okay, so PCBX, PCBY, PCBZ. All right, so this is going to be 120, 130, and then what is the thickness of the board? I'm pretty sure it's 1.6 millimeters, but let's just go to JLC PCB. Upload the Gerber. Oh wait, this is the wrong Gerber. Should it matter? We just need to get to that little dialogue. And the min slot width. But what is the PCB thickness? 1.6. Okay. All right. Let's do 5, and then we'll see how we feel. All right. Normal, rectangle, PC. Oh gosh, that's so stupid. You do this, and then you can't. Oh wait, you can. I forget. There's something that's weird there. All right. Extrude PCB Z. What? Oh, PCB Z. Okay. All right, we sketch. Oh wait, you know what we could do actually in this sketch? Let's just keep as the few sketches as possible. Right, so this is going to be right, let's close all the unnecessary stuff. We're gonna need to wait on that. Okay, so here, PCB hole diam 3.2. All right. So yeah, you have to do one back PCB hole diam. Okay. D. PCB center edge. PCB center edge. Okay. I thought it was gonna work on a mirror. That doesn't make me do two. Wait, let's see there. Now I need a mirror again. I actually wish sketches were had a timeline to them. I feel like that would actually make a lot of sense. Okay. There we go. So this is what the PCB is going to look like. And so the idea is, I guess we're going to use, so let's see. A lot of this is just parts sourcing, man. M3 standoff kit. I don't know. Yeah, that seems pretty good. These are all M3. Ooh, wait, 500. Oh, they're nylon. Do I want them to be nylon? Okay, but what sizes do they have? 15, 20, 6 millimeter, 20 pieces. All right, so yeah, so basically what's going to happen is we are going to have a, it would be really a lot better to import the actual step file. Unfortunately, we really need to move that USB thing, but I'm wondering if I should just do a bunch of positioning cleanup where I actually know the numbers of these instead of having to measure them, because Okay, so the idea was, the thing about the thing about I have a drill press, so I really need to figure out how to fix the bands on that because we have this crappy drill press. But the biggest concern here with doing this standoff thing is that somehow we're going to need to get M3 size holes all into the acrylic. And drilling acrylic is a pain. So but I'm kind of wondering what the other mechanism we could do is cut to size and add a slot and then just slot it in. And then the other part of this that's oh yeah, so okay, so we need to do the CAD and then we need to figure out the enclosure size based on focal length. So um I'm gonna have to cut the acrylic anyway, but I can use the band. I think I can use the bandsaw to cut the acrylic to size. Though even that is so sketch. Acrylic is just so brittle. Well, we're gonna have to do it. So why don't we just okay? Ooh, wait, actually, I have an idea. Okay, so while that's happening, let's Okay. Oh wait, bro. Distracted. Okay. We're almost done. What the hell? Oh wait. I think I know what happened. Bro, what the fuck? Bro, what? Fucking TL draw, dude. Shit software written by JavaScript cookies. Monkeys. God damn it. You've got to be kidding me. Okay, we did it. Holy cow. All right, so if I draw here, nice, and it's fast. Cool, good stuff. All right, so, okay, so this is going to be the camera. Then these are like jacks and ports. And now what we're trying to figure out is if like if the stack up is like, let's say this is the edge of the PCB and we have a jack like this, and let's just draw it like this. Okay. Then, and let's do this. Okay, we don't need that. So the problem is if we, okay, and then let's just, let's say that we have this this enclosure. Let's say we have an enclosure, right? So that this sits on a block. Okay, and we can draw this edge too. So the PCB kind of goes in here, right? And it slots in there. Let's zoom in on this. Then what the problem is, first off, you know, this cable needs to come in here like this. But if there's a big wood box here, you know, like that, with the hole here, then what we need to do is cut. So I think that this is what I'm going to do is I'm going to cut a window, and then what we're going to do is we are just going to blanket this with like some piece of felt or cloth. So this is like felt. So that no light from here is getting in. Felt or cloth or tape or, you know, tape or whatever. Okay, so you know what? Maybe we should just go with that. But now, one thing that I'm wondering about is, let's read what it said. Love this project. Shut up. Decouple loads. Don't hang the DSLR from the PCB. No, that's insane. I'm definitely going to have the camera resting on the enclosure. It's way too complicated to incorporate a boom in this. Oh, God. That would be sick, though. Panel mount is sick. Oh, man. I don't think I want to change. I don't think I want to do panel mount. That would be sick, though. If anything, we don't want any thermal because we want to keep it warm. Um, this is way more than we need. But how do I cut out a window into the wood? I think you have to do that thing with the bands. Oh, that's gonna be brutal. And each device comes with its own, like, how do you even do this? Because, like, if... Hmm. Oh, man, this is complicated because... Let's not worry about that. Let's not worry about that. Oh, whoa. Um... Okay, so let's just do a front view of this thing. So if we have a front view of this, so this is, oh yeah. So, we have a front, you're gonna have this box. And then the idea is that we actually, well, I guess it's dumb. We actually have we have just, when we're looking at it, we just have a panel. This is just a wood board, but then we're gonna have a cutout here. But it's like, how do you make this? Oh, right? So, um, because this is gonna have this jack in here, right? A USB, etc. Headphone jack. you know, the camera. And this is going to be acrylic. And then this is going to be the petri dish. And standoffs with a bolt. The bolt. And actually, these bolts would be like this. Well, this would be a standoff here. This would be a standoff. Standoffs. And then this would be this would just be tightened down. And then this would be like a either heat set, heat set, or just tapped. So the alternative, which I think should be fine, is that so the main thing now is so the idea of this is if this is solid, then what we can do is we can just add a bolt here, a bolt here. And I don't care about what is it called? Called a countersink. I don't care about wood countersinks. Do I really care? No. And these would be in here. This would be a tap or heat set. And then one thing is how to mount. And then one thing that we want is that the center of mass is going to be like right here. So we really don't want it to be that high. But I just don't know how to get, I mean, like, and then if we look at like a bottom, and we have like, I mean, I think we want this thing to be square, even if the top part is off center. So we have this, and then we might as well just make the outline square, but we probably want it to be like, because the wood is not going to be that thick. I don't know how thick it's going to be, and I haven't done, and I'm probably going to have to buy some more clamps, realistically, because I used all the clamps. So the dimensions here are still unknown. But the idea here is that, sort of midway up this thing, we're going to have a bolt go in here, and then a bolt go in here. And, oh, that actually might work. I was worried about them clashing, but if they're far enough... Because there's going to be like a block of plastic, like this is all PLA plastic. I'm really liking this TL Draw iPad thing because it syncs. That's so cool. I really like this. This is fun, man. All right. Um, so the only thing that I was thinking of is like if these were long enough, then we'd have to if the bolts weren't were too long, then we'd offset the height to avoid collision. Um, Do we have any through-hole parts on this whole thing? Yeah, we do. We have the DC jack. So we're going to have to account for that. So, okay, so what I'm planning on, though, is basically... Um, instead of having a window... We are going to, for the front wood panel, we make a slot. So it's just going to look like this. And then we just do a good job of like sealing that up from the back. All right, I think we have a plan. I don't one thing that's maybe worth thinking about is analyzing how the camera is, because the thing is if I rest the camera face down, does it have a natural tendency to wobble or anything like that? I feel like I'm overthinking this. I'm because what I want is that the petri dish is that we have a good coordinate for where the um I mean, can I just move all these? I don't want to redo the routing, but maybe we'll just, I don't know. How do people actually do this, you know? Does this work? Oh, that works? That's so sick. Wait, but that didn't even, it didn't even do it. Yeah, what is that? That's stupid. We should look at the DRC just to see if anything is janky. Okay, so why don't we just record the center position of the first LED and the set? What? Yeah, because like, do I really want to move all this? I mean, it's good enough. So okay, so LED 1 is at X 12.47 and Y 22.672. And then LED 36 is where? It's probably going to be exactly 100 or something like that. Maybe it's like 99. I don't know. But it's good. So this is going to be X is at 112.47 and Y is at 122.672. All right, perfect. So it's literally okay. So that means that you can just add 50. So the center is at 62.47 and 72.672. Okay, so that's from the PCB. Oh, whoa. That's weird. All right, so that's great. So now we have... Wait, let's just keep it on... How do I do Shift S, right? Is this, this? Okay, so this thing... Shouldn't that be in the... It's not in the center because the... Oh, okay, that's annoying. I don't like that. The distance between here to here. Wait, if I just click D, I get a... No, how do I... M? Shift M? I thought, how do I get the measurement tool? Oh. Control Shift M. I was close. And what are we doing? We're picking. Oh, yeah, we want this. Okay, so it's 7. 595. Hey, come on. Oh, wait, that's the wrong one. Where's the little circle? Don't I get a little circle? Oh, that's the circle. Okay, wait. So this is actually way worse than I thought. 12.470. And that checks out because it's like 8 to 12. So that's why we see that difference. So we need to actually shift all of these LEDs over so that those two numbers are equal. So we just need to do 7.595 plus 12.47 over 2, right? I wish they had constraint-based things. The Y though, the Y I don't really care. I just want to make sure that the X is centered because it's gonna look weird. Am I doing the right thing? I think so. We want the distance from the LEDs to be the same. So 7.595. Wait. Okay, wait. So what we want is, so we want to move. So here's what we're gonna do. I think, can we do this? If I select all of this, and then I think I can do move, shift M, and this is going to be, so it broke all the traces, but that shouldn't. Oh wait, actually, can we just do this? You. I thought I'm on blue. Wait, actually. I thought I already had the via. Where did the via go? There we go. Okay, unrouted 3. All right, so I think we did it. So now, where's the position of this thing? It's at 10. It's almost at 10. Oh, realistically, it should just be at 10. But that's close enough for me, because that's 0.03 millimeters. That's close enough for me. Yeah, I should have just set it to 10, though. But that's close enough. Close enough. But I am wondering if I could maybe get... Oh, we don't have the mounting holes yet. Did they ever spawn on Discord? This opens VS Code? Import usage? Why isn't it? Oh, that thing is so annoying. Let's just try to build it. Or maybe I have to do this. Wait, what? Wait, let's How am I supposed to import this? It says, okay, let's just try both options. Let's try this option. Does this give me a mounting hole? Where is this thing? It's probably hosted on their GitHub, right? So should I just be able to see? So this is their general registry. Oh, it's called this? Wait. Wait, did the import... Wait, did this work? I wish I could click to jump to this, though. Let's try to build it with this. Where's the Git repo for it? Oh, here we go. What is the error for this one? Oh, wait. How the freak do I use this thing? Wait, was this the right one? Wait. Is it? Bro, what? I am confused. Okay, well, let's just assume that they're there. Now let's get back to the CAD. So what are we doing? Right? So now we can assume that this point is 60, and then but the Y is at 72. Okay, so this is like the center point of where the petri dish needs to go. So it's that thing is 130, which is 65, right? So the distance between here is what? Wait, how do I make a wait? What the freak is going on, dude? What is the distance between here and here? 65. How is it not exactly 65? Oh. Okay, that's fine. How nice would it be if it went from 20 to 120? Wait, is that right? Yeah, if it went from 20 to 120, then the midpoint would be at 70. Bro, I think we gotta move. I think we gotta move this thing up by 2.672 millimeters. Wait. Nope. Uh. Actually, it's or just this. Did I delete the via? Let's get rid of the vias. Oh, but this isn't going to be enough for that. So maybe this needs to come from here. You know what? But we have so much room here. Why don't we just... But we need a thick trace to ground. So what we'll do is we'll just we'll make this thick, and then this. Do we need a via for that? All right, so that's... Bro, I'm gonna redo this whole thing. How do we... First off, okay, so how do we delete the ground fills? So wait, we need to select traces only. Tracks and vias. I'm gonna go here. We need to get even lower than that. Okay. How do we hide the fills? Oh, whoa, that's weird. But what I want to do is, how do I pad zones? Can I just delete the zones? Oh, but I don't want to delete the zones. I want to disable the zones. Well, we just do it again. I don't care. Just do this. All right. So what I'm thinking is, let's get this here. We'll want this decoupling like right here. Is that weird? That looks weird, man. I think what we'll do is we'll do... This is a cap, right? So this trace is awfully close to this. But we kind of need it, right? And then this is like this. It's like this. It's like this. It's like this. Okay, so the idea is we want to simplify. So the ring is going to the fet. And if that's the case, the only issue is getting back to this ground, I guess. We can't do it? I mean, these are signal paths, but we could via it. So this needs to be a thick trace. This doesn't really need to be a thick trace. So then all of it's going to come through here. I mean, it makes the, wow, dude, PCBs are complicated. Right. You can do that? That's crazy. Wait, why wouldn't we just flip this around? Okay, so VCC comes here. We got the decoupling. We got another decoupling, right? This is a capacitor as well. Then current comes in here, goes all throughout here. And then it flows to here to the FET. So the gate, wait. Oh. That's the ground path. Wait, the pull down could be, all right, so let's do this. Oh, I just want, so here's what I was thinking. So we can move this over here, right? So this is the gate. Yeah, this one's weird. I think we probably do want to like, wait, what about this? G, no, that's bad. This is probably the best. The gate can be a thin trace. This needs to be a thick trace to here or something. Oh, wait. That's pretty good. If that's the case, you know what we should do though? Just move this thing here. Was there a reason that we couldn't do that? We have this here, this, you know, here, this here. And we have so much room. We still have a bunch of stuff unrouted, but I don't think any of that is like real, right? There's one thing that's unrouted. It's probably... What is it? So then this would be the Pico. It'd be the Pico power. You know what? It's good enough. But do we want to fix the traces now? So if I do edit predefined size, tracks, net classes, logic. Wait. Oops. Wait, can't you actually do something like this? Can't you actually like... Well, I guess we wouldn't be able to do that. But I think that you can do that if it's thin. That'd be cool. But so like this via size is small, right? But I don't know. Okay, so are we good here, family? So, okay, wait. Let's figure this out. So this needs to be thick. This needs to be thick. These... Okay, wait. Let's do this the proper way. So the proper way is that we are going to have, okay, board setup. So that's like the main thing. So What is a teardrop? Wait, keep your LED branches? Bro, the whole art of PC, there's so many terms I don't understand. Actually, why don't I just do that? Well, oh, because this doesn't, this has to go to the MOSFET. Bro, this is too much. This is too advanced. This thing is not going into mass production. So I think we're good, except, so you know what? I'm not even going to do this thing. I'm not even going to do this thing. We're just going to go back to our use net class with. Mm. Actually, I have an idea. If we did this, Wait, hold on. We do X, V, and then we do X, V, and then we do V. So then this whole thing is not necessary. Oh, wait. Because we could just do this V to there. Because then this whole thing will be a ground pour. And then is anything missing ground? Just this. And so we should be able to just do V, right? We could do that, but when we... So wait, hold on. So unrouted 4. So I just want to see that if we go on to... How do we do this thing again? How do we make the zones again? We do this. And we're going to go... Can we just use this as our... Of course not. So then now... Unrouted 3, because this thing... So we could just add 2 vias there is what they're saying. So this actually doesn't need a thick trace, right? This is just a pull down. There's not a lot of current is going through there. And then what we want to do is we want to also... Nice. So we just stitched to the ground plane. And then now this thing has so much... Okay, so the... I don't like the look of this, but that's fine. But wait, do we even need this trace? That's what I don't understand. It's still mostly subtractive, and they reclaim it. Interesting. But they do a photoresist thing. Okay. I never did the photoresist method. Maybe we should do that. That sounds fun. We just don't have the time. But I never did the photoresist. like the whole thing is copper. So if we're tracing this out, you know, VCC comes in here from the, wait, so let's now look at this. So we could leave these explicit, but they're basically like, all right, let's just let the plane do the work. So we literally don't even need this thing. We need the via though, right? Wait, do we need the via anymore? I don't even think we need the via anymore. So wait, let's, that's going to delete the vias though. We don't want that. We want to delete this, delete this. What just happened? And this is this ground. Okay. Wait, so we don't need these vias anymore, right? And this isn't even going to be delivering that much current, right? So we can use our normal. I wish someone that knew what the heck they were talking about would come in here and be like, dude, what the hell are you doing? What you're doing is stupid. I feel like I did learn a lot on this PCB though. So two vias, and then we're at the ground. And then here, this we don't even need two. This we don't even need two of them for, actually. Is that a little close? But are they tied? These are not tied. I think I'm gonna... So wait, this... Oh yeah. I don't know what's better. But now we have this island. But if I instead do, then we have all this red here. I love this stitch to ground thing. This thing is sick. Wait, but I want to make it look nice. The pores are so sick, man. I wonder if I can I select, grab, whatever. It's fine, right? It's fine. Let's just, BCC decoupling. Actually, we probably could just put, here, why don't we do this? Oh yeah, we need to do, we need to do, let's put that. I don't think we're going to have a problem with thermals. I think I went pretty overkill on it, actually. Let's see, did they respond? No. How the hell do you add the mounting holes? That's like the last thing we need to do. Can we look at the DRC? Wait, what? Wait, I don't even understand what this is. That DRC message means you have a through hole pad, whose drill is as big as or bigger than the copper. Wait, big what? What is it? Okay, wait. So we need to go to the footprint editor and check because also once these connected and that's not right. So wait. What? So now what I want to do is, so we're going to have to, okay, so, wait. So we're going to have to, here, so we have the thing. So, I don't know if we have it yet. Okay, so now I'm going to open up actual KiCad. Oh, okay, great. And we want to open up recent illuminator. And then we want to go here. And we have this whole crap. But what we want to do is we want to file. Oh, wait, we just want to do this. Add and then USB. Yeah. So now if we save this, go to the PCB, and then we get changes. So if I were to run DRC on this, would I get the same thing? Wait. Oh. Can I search in here? Bro, that's what I'm saying though. But like, what I don't understand is if we were to close this, yeah, this headphone jack. These are PTH, but so if I run DRC, am I gonna get this PTH thing? Run DRC, bro. Does anyone have like a KiCad, like run DRC t-shirt? That's so funny. Oh my god. That's silly, bro. I don't even think that that is for, like, I don't even think that's like, there's a silk screen overlap. But the thing that I don't understand is that like this says unrouted 0. I think the simplest solution is if we go here. Okay, wait. So now it doesn't want me to route these. Okay. So let's just do that for this too. Mm, okay, unrouted 3. All right. So I think we're like, can these fools get back to me, bro? How do you import this thing? What is this warning? Zero errors. Let's go. That's cool. What changed? Do I have to run auto sync? Maybe I just didn't sync. Is that true? Did we do it? No? Dude, this is so stupid. They're like lying to me. These guys are so... Their LSP is slow, too. Screw this guy. This guy doesn't know what the hell he's talking about. How do I find an let me go to their thing and see if I can find... These fuckers. Fuck these fuckers, bro. Bro, these guys are lying to me. I'm so sick of these bastards. Wait, is it working now? I doubt it. These people are bullshit. Fuck God. I'm on the latest thing. How do I use a mounting hole? This is what I have. So where the fuck does this shit live, bro? I'm getting pissed off, bro. Dumb. It's dumb. These people are lying to you that I mean, whenever stuff like this happens, you gotta take a step back and be like, what? What if I just do from mounting holes? Okay, fuck it. We're just gonna move on. So the last thing we do is we add 4 of these things. Okay, then we're gonna because seriously, I can't be bothered with people's shit. Right, oh wait, I messed that up. Okay, so now Shift M, move item. I think you do it differently. You just say, okay, so this is going to be oh, you've got to be kidding me, dude. You fools. They need to get back to me, bro. All right, I'm done with them. I'm done with them. Okay, so this is the PCB. We are ordering this thing. And we're also going to oh wow. That's actually crazy. So we want some crosstalk. So we want to filter at like 620 because we can get this tail end. We don't need the peak because we don't want the crosstalk. Okay, so what we want is like okay, we're getting ready to order this thing. And I think I'm going to order it after the stream cuz it always takes a lot longer to do this. Oh, wait, what? Wait, what? What is happening, dude? Why doesn't Control F find that? That's so. As I don't know what just happened. I don't know what just happened, honestly. That's so weird. All right, so 620 is what the standard red is. Wait, is that in my? This would be sick. Blue. All right, so now we're just trying to find out. So I guess we do want to. That's too high, right? So, I mean, that would work. 520. So, okay, so we're gonna get the blues, the green. I'll probably get this green. 3.2 volts, 20 milliamps. This is probably what we want. See. All right. That will work. That's good. A yellow light. That's perfect. If we look at the data sheet for that, that might be perfect. 20 milliamp. Oh, baby. Oh, baby. It looks so nice. It looks so nice. So we just need to get the right. So wait, hold on. Hold on, though. That might not be right. Because are these 0603? Okay, good. Nice. So the LED package is 0603. Those are teensy, man. All right. So at least we've future-proofed it for. Okay. Wait, this doesn't even have a data sheet. What the fuck, man? Is this actually the right thing, though? Okay. I tried that, didn't I? Oh my god. Am I really gonna rebuild? I might rebuild. Because I did want it to work. I got it to work. That's sick. Okay. All is well, bro. All is well. I think it's time. I think I need to make some food. So, um, given our design, what Okay, so we just need to add to our bill of materials 150 ohm. And so that's for M cherry. And then we want to add a UV one. So let's try to add a UV one. So this is for blue. Blue would be so sick. $395 to $405. That'll work. That'll work for sure. That's not the right form factor though. Ugh. They don't have UV lights that go purple. There's always such a long tail of random stuff. We can do this later. Let's get back onto the CAD. Okay, so we need Okay, then we're also going to get 500 ohm resistors. And we are going to get, let's see, both of these are the same, right? So it's just, we're just choosing on cost then. I like shin light. Let's see, do they give me a spectrum though? They should. Shin light usually is the same format. Alright, that looks good to me. Okay, so this is the purple, the 300, and then this is the green for M cherry. Oh wait. No wait, green. Are we getting green? What green? Wait, we were gonna get a green. We're just gonna get all the LEDs just for funs, just for funsies. Okay, so then green is C965815. Okay, now we just need the yellow. Where did we get the yellow from? But that's, yeah, that's perfect. Okay, so we need yellow C96580 150 ohm, then purple C73719898 500 ohms, and then green. Oh, we should get a red. We should get a red. And a blue. We should get a blue as well. This is silly, but Wait, which blue did we end up getting? $965,807. And that was 120. But that's already in the bomb, but we can still look at it. We can use the 120s. All right, cool. So we have 4 colors, and now we're... Bro, fuck it. I'm ready to order this thing, dude. This PCB has no errors, just warnings. I'm pretty proud of this one, not gonna lie. So, um... So, okay, wait. Oh, we're gonna recompile. That's right. All right, so let's recompile because we figured it out. Wait, did we? What is arrow? I think if I do this. Okay, so you can't make an array. So let's just do... Oh, wait, but you know what you can do? What the hell was that? I think we're good. Let's build this thing. Is there any changes? Okay, good. Okay, the PCB is done. We're closing this. So now, but do we have a step file for the board? Layouts, production. Oh, you know what we have to do? Actually, we have to open up KiCad. We need to redo the fabrication. What the fuck is going on? That was so weird. How did that happen? Yeah, I'm gonna make some food. Oh, wait, what happened? How did that happen? If I rebuild, does that happen? You can't place it directly on top. It's finnick. Wait. Oh, but it like. That's weird. Okay, I think we're actually ready to do this. You can use, a transistor and a computer so that you can programmatically take a picture. So All right, so it's CAD time, baby. So I got a filter. So wait, how do I get the step file? Oh, baby. Can I move these? Oh, it's so cool. Baby, baby, baby. Bro, this is my freaking board, bub. Bubby, this is my freaking board. This is my freaking board. Man, all these projects they do take way longer than you think they're gonna take. Now I think I can group the whole thing, right? I think we're good. Is that really on there? It's on all of the parts. I bet someone's job is literally just making sure that there's a good spot for the logo on the step file. That's goofy, bro. I mean, it's crazy that it's just an. I mean, first off, this optocoupler is massive, man. I feel like. No, I like the idea that it's isolated. I do kind of wish I did panel mounting, honestly. One thing I'm going to keep an eye out for now when I start to look at other manufactured devices is what's panel mounted and what is the enclosure designed around the thing, or is the thing designed around the enclosure or whatever. Okay, I'm gonna go on a walk. We're gonna come back pumped. Gonna get some ice and LaCroix. I'm gonna get freaking pumped. All right. It doesn't show the pads. Is it supposed to show the pads? Can I export it again? Baby, baby, baby. Oh, sick. Nah, that's fucking awesome, man. That's so cool, dude. Look at that, bro. Okay, I'll be back. Yeah, alrighty. Alrighty, bro. Alright, so I'm gonna get a big cup of ice water. It's hot out today. Alright, let's get this ice going. It only took how many hours to start designing the first part? Way too many. Alright, let's do this thing. Okay, so here's what I'm thinking. Yeah. Mm. Actually, okay. Well, it's gonna see my email anyway. This one I don't even care about. All right. So how do I do this? I need to upload. What? They have a hold on. What? Importing geometry from other. The frick. I don't care. Oh, I don't think they have multiple part things. Okay, we're not gonna use zoo. I realize you can't like import like you wanna. Do we want it level or do we want it raised? I could honestly see the case for it being raised. Alternatively, I've never used. I remember I bought like a bunch of wood threaded inserts and I never actually learned to use them.
Hey, it's Sean from Tested, back with a new shop tip. Today, we are going to be taking a look at threaded inserts, different types, and where you might want to use them. So, threaded inserts. In the instance where you may need to put machine threads for a machine bolt or screw into an object, whether it's wood or metal or plastic, we're going to talk about the different types used for different mediums. So the first one that we'll look at is probably the most common that you will find at like a typical hardware store like Home Depot or a mom and pop shop or whatever, and that's threaded inserts for wood. So sometimes a wood screw is not what you need. For example, I needed to put leveling feet on the bottom of a wooden cabinet, and I needed a machine thread for that leveling foot to go into. So probably the most typical threaded insert you're going to find for wood are these T-nuts. And you'll find them at Home Depot and other places like that. And you simply drill a hole the size of the threaded portion into the wood, and you then just hammer it into place. which I've done already for you. And the teeth of this will bite into the wood, keep the threads from turning, and give you a machine screw threaded insert. These are fine. The problems you run into with these are they typically do not sit very flush. So if you're in a situation where that's not going to work for you, you're going to have to look for a different type of insert. And I've had them tear out of the wood before, both just popping straight out or actually tearing the wood. But those are typically under extreme circumstances. And for most areas where you're going to need a threaded insert in the wood, these will work fine and they're cheap. My particular favorite are these inserts that you screw into the wood. So just like this, you drill a certain size hole based on the manufacturer's specification on the package. And then they had a hex key opening on one end that you then use to drive into the wood.
Let me go see what I have. Oh, that's pretty sweet.
So it has these coarse blades on the outside that really bite into the wood and cut well. And then you simply screw it down into the wood until it's at the depth that you need. And we'll switch to the more leverage. And there you go. So we have a threaded insert in our wood that will allow us to go in. Now they make a few different ones. They also have the flanged version, which I'm a big fan of because it gives you a little bit more strength. For example, if you're worried about this pulling out of what the wood that you're putting into, you put the flange on the back and then thread it from the opposite side, and then you have the additional strength of this flange over here that is going to make this far less likely to pull out than just the blades on the outside alone.
I won't be able to do that.
So those are the ones that I would get versus the T-nut. So those you can usually find at the hardware store without having to do a special order. Okay, so next we're going to talk about doing plastic. So I do a lot of plastic inserts into plastic for 3D printing and other fabrication projects. And once again, you can thread into plastic. I thread into like directly thread into plastic. I've done that with lots of 3D prints. You just model the right size hole into your 3D print or drill the right size hole into your.
Okay. All right, so let's get on. So here's what I'm thinking. So we have this PCB. Let's fix this thing though. Well, it's not even relevant. So this is just the PCB. I'll use this because it's going to be fast to render. But here's the idea. So we're going to have another part. And this is Bro, I'm so overthinking this. Okay. I actually don't think that's enough. Oh my god, dude. Onshape is literally... Wait. Wait. Ugh, Onshape is literally terrible. Wait a minute. Let me think. So I think it is going to be, so hold on. So we need to make a variable. This is going to be would outer 2. What is wrong? I love, bro. I hate this stupid program. Wait, what? Oh, and yeah, thanks. Dude, this program's stupid. Okay, this is silly. What I'm trying to do is I'm trying to add um, some indexers so that I can okay, so if I extrude these out, here's what I want to do. Wait, that's not even right. Oh god, I hate this. This thing is so dumb. Wait, did it do it? Alright. The thing is, actually, computer's slow, bro. Let's close all this stuff. Uh, then we're gonna make this wood thick. Oh. Oh, God. I don't like using these tools, man. Um, Cause see here, this is where this freaking, you know what? I don't even care. I don't even care. Once it's loaded, it's actually pretty fast. Bro, come on. Okay, wait, but now that it's in the right spot, maybe we could just delete it. So if we just delete these, that's not what I wanted. I wanted to. Okay, so now we're actually finally at the point where we can um, Oh, really? Bro, what is going on? Oh, I see it. Okay, I found it. So then we need to like take a ruler and like figure that out, I guess. So it's like way at the back. So it's like that much. Wait, where did this 15 point? What is a focal length? But you can change the focal length. Bro, optics is crazy, man. I mean, like, how many photographers know this stuff, bro? Like, maybe we should read a data sheet. I want to see how good its diagram is. I don't think that's right. Oh wow, it has a Wikipedia page. Oh, that's so cool. That's how that works. That's crazy. An ultrasonic motor? That's nuts. That's how they do it? That's crazy. It's discontinued. Wait, 18. This isn't even the right lens. A totally different lens. I don't even think that's right. Whoa, wait, is that right? Yo, that's insane. Okay, what about the other one? This is not even the right lens. Dang, man. Wow, so this lens that I've been using, that's hilarious, bro. For my dumbass live streams, I've been using $1,000 lens. That's crazy. Pretty cool though. Okay. Um I've Okay, wait. So Bro, what just happened? Come on. ChatGPT, stop being so stupid. Stop being so stupid and do my work for me. Bro, what the fuck is going on? Is it gonna do it? Okay, so why don't we just make it 2 feet? I mean, obviously it would be nice to actually learn this. What is this sensor to dish? Oh, petri dish. Lol. All right, so we're just gonna make them 2 feet. I'm not dealing with this anymore. This is a total, like, one of these things where it's like, it's gonna be good enough, and if it's not good enough, we'll figure it out later. Okay, so okay, so we're making the box 2 feet. I know that this is the sensor, but I don't think it really matters. I really hate that ChatGPT just doesn't work on Firefox, man. Okay, let's do this thing. So, okay. Hate that. Give me. Oh my god. Oh wait. No, okay, that's well. Either no, yeah, that's fine. So the distance is going to be the same as. Oh wait, am I doing 4? I guess I'm just gonna do 4. 4 is fine. This is a dimension that I need to figure out. Should I just do M5? Let's see. Because M6 by 15. Okay, so M5 by 20 is kind of what we have here. So we can't use the M6. We have M5 by 20 socket caps, and that'll probably do it. So maybe I'm going to switch to M5s. So let's see if these are the M5s. That's an M4. That's not right. These are probably M5s. These might be M6s, actually. That's M6. Maybe these are M5s then. These look like M6 then. Yeah, that's M6. So which of these freaking guys is M5? There we go. Okay. So I think the biggest challenge and I wonder where the drill bits are. I think I have a drill bit set. Let me figure this out. Because wait. Let's design it sort of. So we're gonna use M5 because M3 we don't have any of these threaded ends, and I want to use them because I want to use them because I want to be able to disassemble the device. So if we have M5, oh wait. Oh no, that's fine. Yeah. So M5 is fine as long as we go back to the PCB mount part. And then when we go here, we need to look at so please for the love of God, if I change this to 10, they all change. Thank heavens. That would be so freaking annoying. So we're doing M5, so we need to look at the document. So let's close all this because we chose, there we go. So we have M5 head diameter is 8.5. So let's make it 9. And then this is going to be 5.3. Why did I have it 4.3? That doesn't even make sense. Okay, great. So we're going to have this bolt here. So yeah, you flip it upside down. You put this plate on it. It'll sit in here and it'll be indexed by those little pegs here. And then so it'll fit nicely and then you can tighten it down. And now we just need to come into here and we basically need to figure out. So one disadvantage of this design nah, wood glue is strong. People say wood glue is strong. I'm gonna trust that wood glue is strong. So when we sketch on here, we are gonna sketch a. So we're doing the M5 one. So let's get some measurements on that. So at the top, 6.5. So I'm gonna say. So my variable studios are a form of documentation, right? So what I want to say is M5 would insert M5 So the suffix hole, and that's going to be 6.5. And then $9.25. So if we make it 10, so that's more of a minimum. So okay, so we're gonna wood. Oh my brother. Whatever. Wood insert hole. Why can't I select the freaking actual planes? Ugh, whatever, bro. Whatever, man. I don't like this program. It was tolerable, like... So someone tell me why I can't select any of these. There we go. Okay, we're not gonna get a cat of this wood insert thing. But that's actually kind of an issue. We should probably do... Okay, let me go get my keys and we're gonna go look for what metric drill bits. Because the thing is... What... Watch this thing freaking freeze again. I'm just gonna read it on my phone. Oh, really? I don't think I have a 6.5. The other challenge with this is that it's not side. It's not drilled from the sides, drilled from the bottom, which is significantly harder because you can't use a drill bit. So I'm gonna have to like... And then placing the hole... Placing the hole, what I'll do is I'll just make a marks with this thing. I'll just like set this to whatever it needs to be, lock it, and then scar the wood, I think. And then I don't know what type of wood to use. I'm really not much of a woodworker, but let's see. Let cure overnight? Let me look at Home Depot. One half inch, 4 by 8 feet. That's plenty. I think that's plenty, right? 32 square feet. I think they probably have. Oh. All right, let's do MDF. I want to do. Wait. Wait, actually. Because I don't want to pollute my yard, bro, when I cut this. I think I want to make the box today. I have time to go to Home Depot, I think. Maybe I will do ply. Yeah, I was thinking of the ply that looks gross, but they have the nice ply. All right, so I think I'm gonna go ply. I think I'm gonna live dangerously. We'll see how it goes. So then, man, I want to get to the depot, bro. I want to go get this thing made. Because this is gonna be a pain to make. Don't get me wrong, brother. This is going to be a pain to make. Oh, great. We have to freaking... Wait. Oh, wait. Do we already have it? What? Oh, because of the part? Okay. So now we're basically ready to... So the orientation actually matters because, yeah, we want one of these short ones. Oh. Um... Yo, this is so tall. 2 feet? We need to make it shorter than 2 feet. Okay, so we're gonna make it point. Um, that's way better. Okay. Okay, so now what we're gonna do is we're gonna design a part that's, I guess we're gonna do a 3D printed part. Okay, so the idea is that when we make this, here's what we're gonna do. This is how we're gonna make this thing. So we're gonna like put one of these boards down on the ground on something flat. Then we're gonna put two of the long ones with the glue it, smush it together, and then put two clamps on the side and clamp it down really tight. And then what that will give us is that this is aligned to the bottom. Then we're gonna do the exact same thing on the other side. Put the glue in, slide it, bend it slightly, slide it over, clamp it down, and then we'll have that. Okay, now we're gonna need to put holes in here. And then all of this stuff is 20 millimeters. So basically, when we design this part, we basically just need to take, I mean, these are coincident, right? But this is a much better looking box than, plus we use way less wood. So like, okay, so wait, I think the next thing that we need to do, what is this? Part 2, on part 2's bottom. So this is part 2. Let's see, what is the Z height? Of the max. We're not going to get crazy with the shape. We're just going to pull this out. Did I already group everything? $11. So we should be able to make a 12 sketch. What? Oh, wait. This is going to be, let's just do, okay. And now if we go to the PCB, great. Oh, okay, that's right. Plus, what is this? Here to here is 3. All right, so this is going to be 15. Why is this raised up? It's raised up because of indexing. I think that's dumb. I think I don't want to do that. Because I mean, we need to design. Because once this is sealed in there, it's gonna be hard to. Well, I guess we're gonna have a detachable top, so we can like reach down in there, but it's not ideal. It needs to get really dark in there. Yeah, what if we just. I think we don't even need indexing. You just turn it over and you do it. Babies need indexing. Update, update, update. Oh, wait. So then what we're going to do is we're going to have a big piece of cloth that's going to go and like tape in there. All right, I think that's good. I think that's fine, right? What's the depth of this? 7. We're gonna tap it. We'll just tap it. That's fine. I think it's a 2.5 anyway. Yeah, from the looks of it, it's 2.5. You know, one thing that we didn't do was art. We need to do the PCB art. God, do we need PCB art? We obviously need PCB art on the back. We have an opportunity to get like a super dope image and it doesn't even cost anything. If we open up the, gosh, we gotta open up this whole thing. And then it's gotta open up the extensions and then do all that. Okay. I forgot how we do the graphics thing. We have a back silk screen. It should probably be something I draw. At the very least, we need a circle that's probably like, yeah, like 50. So let's edit this. X60, Y 70, radius 50. That's actually really close. Can we get an arrow? What? 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 How do I enter? Okay, hold on. I'm totally doing this. I'm making it. And then let's do a just a point. Can I just draw like a really small circle? 60, 72. Is it gonna interfere with the lights? No, not really. How could I forget about the petri dish art, bro? Wait, have we really been streaming for 11 hours? No. What? Yeah, that was wrong. Wait, why does it say 16 hours? What should I do for the back? It's obviously going to be something I create. Oh wait, actually I have a better idea. Does it look cool though? All right, there we go. We did the art. So now what we need to do is we need to save and export this. Oh, that's so cool. Wait, hold on. You know what we didn't do though? I don't like this one. I'm gonna erase this one. Oh my gosh, I cannot do this. All right, that seems pretty good to me. So now we need to export this thing. Export to an SVG, transparent SVG. So if I open this SVG, so now how do I add my file, import, graphics? File, where did it download to? Just downloads? Okay. Group name, art. Oh wait, not locked. Okay. How do I scale it down? So wait, let's just figure out the dimensions of this thing. I think, okay, if this is, so we need to do 0.25. So let's delete, um, import graphics. Wait, I think it, all right, that seems cool. We don't need to go too much harder on that, but that's awesome. That's dope. Okay, so we did the art now. Okay. I think all issues have been handled, right? Alright, we did all the to-dos. The only thing that I can think of that maybe is not is that this is not fully done, right? So this bottom plate that's 10. We can make it deeper. It'll just bottom out. So I think I'm gonna okay, well we need to cat out one more part, right? All right, let's build the absolute simplest part that we can think of. And then we need to buy blackout felt or something. Um Oh, but you know what? We're not even close to done. Um because why do we need Wait, let me get the flocking sheets. We just order them because we're going to need it no matter what. All right, so like, uh, okay, I'm gonna buy the flocking stuff. I think that that'll be good. We'll see if that becomes a problem, but we have, okay, so we have an answer for that. Oh, we need to make this taller. That looks so tall, though. So, okay, wait, if we have the box here, I mean, this is only going to be 15 millimeters above this. So then that means the distance between here and here, which is the, so we should be able to make it, and it's to the sensor, right? So we're going to have even a little bit more. So I think if we make it 275, we'll be good. Because this is just too tall, man. This is too tall. All right, 275 seems good. Because then, if the camera's like right up here, and this thing is, so, okay, so we need to, so, oh yeah, so the way this is going to work is we need the standoffs kit. Okay, and then we're just gonna have to figure out a way to score and use that drill press to drill holes in the so okay, so wait, so let's see. We're gonna use a 15 millimeter. We get 10. What's the depth here? When we go to print, we're gonna need to make sure that that's correct. Let's go to this. What? What? Oh, there's some sketch that's still living. What? What the f- Oh, wait, was that it? Oh, 6. Okay, that's good. That's good. I think we need to make that, we need to make that a heat set insert, though. And the reason for that is that the 6 millimeter length of the standoffs. Oh, actually, you know what? That should be fine because we have the 2 millimeters or 1.6 millimeters from the PCB thickness. Okay, so um this website is fast. That's actually kind of crazy. Metric M3 length is 15. They don't have a 15. Let's do 16. That's exactly right. I think you have to be signed in. Let me go figure out what my login is. Where's the login? I love how fast this thing is, dude. It's so sweet. Beautiful. We're getting back into that flow state, baby. Wait, can we actually? I think here's what I want to do. I wanna delete these parts. We can redo the grouping. This is just the PCB mounted. So, insert. No, I wonder if they have bolts and screws. They don't have standoffs, which is fine because we don't need it. All right, so that's good. Now we need to just duplicate it. Oops. What was that? Okay. Here's what we want to do. We want to go like this. This. I love that. I love that. That's great. And so now we want it on that circle. Oop. I think there's actually a way to safely recover that. And I feel like there's probably a faster way. You know, I wish that like an AI would watch me work and be like, actually, did you know that there's a better way to do this in Onshape? Because like, man, I watched a video of some like a professional using Onshape and I was like, whoa. Why am I not getting it? There we go. Okay. So now we have the create part studio, rename, diffuser. I am the diffuser. And we are just going to make this the exact same. This is literally just a rectangle. It's going to be, so this is going to be PCB X, PCB Y, and then we're going to just do 3.4, I don't know. It's an M3. And then this is going to be 5. This is going to be 5. Oh, wait, is there a center edge thing? Okay, let's do that. Okay. Here. P. Okay, and then is there an appearance thing? How do I change the appearance? Edit appearance. It's like translucent. It's like matte translucent. Wow, that's so sick that we have opacity. All right, so now we can just insert diffuser. I am the diffuser. Okay, so now we're gonna do. Oops, I actually want to delete this. Create assembly. Okay, we still have one more part, right? But Now that I was kind of getting in the zone, you know what I mean? Oh wait. Oh wait, actually how we do this matters. Oh, but that is correct. All right. Sick. All right, so the only thing that's kind of concerning is that there's a little gap there, but personally, I'm not too worried about it. Because, I mean, this is a way bigger concern than the... But what I might do is I might, like, get that tape and also put some over the front. Okay, so we do have one important part left to do. But... Oh, I got my stuff. Oh, let's go, let's go, let's go. So I got my stuff. So let's see if we can actually get this working. Okay, so we have two things that we... Alright, so I have three things. Okay, so I have headphone jack adapters. So basically the MCDC2 cable, which we'll see here, which we'll test out in a moment. Okay, okay. The thing about this is, because we have a remote, so that's a hold. Oh, that's a hold button. Interesting. So I don't know if it has the focus control. It doesn't seem like it has the focus control. We could take this apart and see how this thing is implemented. It actually seems like a fun thing to do, because I'm not going to use it. You know, why would I use that? When I have transistors. When I have transistors. Okay, so here we go. So this is really what I paid for. I paid for this hilarious proprietary cable that who knows what the heck that even is. And what's hilarious about that is apparently it's also labeled as a GPS port. Like for like global positioning system. Okay, anyways, I'll plug I gotta go to the bathroom, but we'll plug this in and see if we can take a picture. Okay, so let's do this thing. So we have this, and this is an extender cable. We don't need the extender cable for right now. So this is a 2.5 millimeter TRS, which I guess is interesting. Okay, so let's plug this in. So I have my fake battery. And let's plug this in. Okay. Okay, so we have power. And we're going to turn this thing on. Get the preview mode. Okay, so the weird thing about this is, I don't know, it seems like you hold it. Should we take this apart? I'm not going to use this thing. Let's take this thing apart. And then the other thing that I got, so the last thing is this special, very snug fitting USB cable. And so basically we have two things to test out tomorrow. Maybe I'll get it tonight. I'd really like to test this. But I'm going to have to clean up soon. Because I'm going to go to Home Depot and I'm going to try to buy the wood. And we're just going to try to assemble the box. I'll probably hop on live later to do that. One thing that so what is the outer box size? Like what? Like first we're going to need to generate a cut list. But basically what I want to know is, okay, yeah, so we're talking about like, so that's this length, right? 155. Okay, so I need to do some math. So before we go have fun cutting this open, let's just figure out how much wood I need. So I need, okay, so I decided to make 2 boards of 155 point. So so I decided to make the enclosure out of 2 boards of 155. Wait, you know what? A 4x8 plank. I'm wondering if we can get that in. We'll probably need to bring some bungees, but okay, so 2 boards of 155 point what? 0.4 millimeters by, what is it? 275. I think these are 130, right? Asking how many square feet is dumb. Um, Like, it's probably not going to know that there's a satisfiability problem in there. It would actually be interesting to know. Do we have plywood? Let me go check this shed. So yeah, so before we order this, we actually definitely want to test this thing then. So the thing about that is we cannot cut this cable open. So we're going to do this whole thing with the adapter. These are loose, man. What the hell? Let's see. Okay, we'll round trip it. We'll round trip it. If this still works like this, then we know that it's all good. It's nice they give you both. All right, it worked. I don't really get how to use this thing, but it took pictures. So that's good. Okay. So what am I worried about right here? This is probably way too much wood. Oh, this is a big project to start at 6 p.m. And then clamps. Oh yeah, so clamps. I need a ruler. 160 millimeters in inches. Oh, it's only 6 inches? Is this thing tiny? What? I wonder how he did this. That's
A few
actually...
weeks ago, we looked at gel electrophoresis, an incredibly versatile technique used for at least a dozen different types of analysis of different biological molecules and their interactions. As a quick reminder, the technique works using a special block of gel and electricity to pull molecules through it. You put your sample and cremate holes in the top of the gel, and a special mixture
So he used a scroll saw. I'm not going to have that, so I'm just going to 3D print
spread out
it.
as lighter molecules in the mix move faster through the gel and form a series of bands made of molecules of known size. You can compare the bands that your sample produces with these control bands to gauge the size of your sample molecule. Of course, this is a simplification, and you can do a lot more with gels. As part of that video, we looked at how you can make the special tank you run gels in for only a few dollars worth of parts. The tank works well, but there was an issue I noted, which is actually seeing the bands once you run gel. In theory, you can just tilt the lights in the room, throw on some UV blocking glasses, and shine a blue or UV light on the gel and see the bands. But in the case of DNA electrophoresis, the amount of DNA in each band is minuscule, and even though the DNA is stained with a dye that glows under UV light, the amount of fluorescence can often be below what humans can easily see. Luckily, there's a device that solves these problems called a gel dock. Basically, it's a special box that replaces our shoddy vision with some nice calibrated silicon, i.e. a camera. Normally, gel docks are crazy expensive, easily $8,000 to $12,000 if not more. And yes, it'll come with a lot of bells and whistles like a screen, automatic controls, but in essence, all it is a box with a hole in the top for a camera, a transilluminator, which is just a bunch of blue or UV lights, and a filter on the camera to block that blue or UV light out. So of course I built one, and I'm honestly really impressed with the results. I got the basic blueprint from an article in the Lab Times about building a DIY gel dock, and I've linked that in the description. In the paper, they're pretty clear that you don't need to stick to their exact design, and lots of variations will work. So in this video, I want to go over what I ended up making and the parts I used. Then we'll look at some tests and other fun things that this device can do. Let's start with the camera. I'll be using my Nikon D3200 as the camera because it can take long exposures, and gives me lots of control over the settings so I can take the best picture possible. You can probably get away with a cheaper camera, but your results may vary. Personally, I really would recommend a DSLR for this, as my best results came from a 20-second exposure, which simple point and shoot cameras can't usually do. I figured out the minimum focal distance of my lens and then designed a box around that. I made all pieces out of some thin.
The minimum focal distance. Okay, yeah. I don't know why I made it so complicated. I mean, I was just like... That was just dumb. So...
Yeah, as I wanted all the walls to be opaque but still lightweight. You can use other materials, this is just what I had around. I cut everything on a table saw to make sure all my edges were nice, as the goal is to make this light proof, so we want to avoid any gaps. For the hole in the top, I just drilled a small pilot hole and used a scroll saw to cut out the rest. I've designed it to fit so that the lens fits most of the way in the box, but will rest on the edge of this hole. I chose a spot on the lens where it flares out that's well past the focus and zoom control, so they won't get bumped if the camera gets moved. My box is 15 centimeters wide and 25 centimeters tall, but designed yours around your camera and lens. I used some epoxy to glue the box together, and once it was cured, it was time for a paint job. The outside just got some blue spray paint, but the inside got a coat of black 2.0, the darkest paint currently available to consumers. In theory, any matte black paint should work, but I had the stuff, so I figured I might as well use it. With everything painted, I added a small ring of felt to the top hole so that I don't scratch my camera, and so the lens has a nice soft place to rest on, while also filling in gaps so the light doesn't get in. With that done, it's onto the illuminator. For mine, I picked up some cheap blue and UV LEDs. Mine are flathead because I'm using these in another project you'll see soon, but I don't think it really matters. I also picked up a $1 Tupperware container. I marked out 16 holes for the LEDs on the Tupperware, and then carefully drilled them out.
So, the resting point of the thing, I don't really know how we're gonna do that. Especially if this is like unlocked. You know what? Wait, you know what we can do? Actually, we can do something. We can do something here. Okay, so wait, we need to test if this thing works, and the way that we're gonna do that is that we're gonna connect. So wait, what is the pin out for? I think the tip, right? I know there's cut list optimizer, so don't come at me with that. So okay, so I need a little piece of wire. All right. I should be allowed to just short the thing. So we're going to try that. Okay, so I need a piece of wire. Okay, all right. So, if the calculations are correct, if I short this to here, it will take a picture. Okay. And it didn't. What about the ring and the sleeve? The ring and the sleeve. So I got the focus to work. So by holding the ring and the sleeve together, so what the hell is this thing doing to get this picture to be taken? All right, I need a screwdriver. That makes no sense. because there's only 3 signals. So, and I've connected all. Oh, crap. Well, that means I'm glad I didn't order the PCB yet, you know? All right, let me get a screwdriver. Wait, there's one thing that I didn't try, which is shorting them all together. Oh, okay, I did it. Okay, so I have to short all 3 of them together. So what that means practically for me is that I have to use. Aha! That's so cool. Okay, so let's look inside this thing. I don't know why, but you have to tie him. I'm so glad that I got this before I ordered, man, because that would have been more annoying to debug after the fact. All right, here we go. So, standard build process. You have a injection molded part. Okay, so you have a button, and it's hey, hi, and okay, so the PC, there's 2 PCBs. There's yeah. Oh yeah. Okay, and so underneath here, it basically slips under and it just holds the contact pressed. What I don't understand though is how. Wait, can I just pull this off of here? Oh, there's screws. Okay, hold on. Let's undo the screws and see what's going on. Okay, we'll go in a second. I think the product. The only thing that I don't exactly know is, there's there's kind of two options. The first option is we take the whiteboard down, which I kind of just want to leave the whiteboard there and just buy more clamps because I need more clamps. So I'll just buy more clamps. I'm just gonna buy more clamps. There's not even I'm not even asking the question. I'm just telling you we need to buy more clamps. And so let's see here. I mean, it's literally just a breakout switch, but I don't understand how this thing works, because when we press this down, how does this thing work? Okay, here's what's weird. So, okay, so this camera, so I got this thing, right? So I got the cable that lets me take pictures with the remote, right? So if I screwed this back together, I could click the button and it takes a picture. Sort of. It does this weird thing. You kind of have to like hold it. So what I found out though is if I tie, so okay, this is called a TRS. Tip is the tip, ring is the middle, and sleeve is the outside. And I'm so glad that I didn't buy the PCB yet, because otherwise this would have been a total headache to debug. But so if I tie the tip or the sleeve and the ring together, it focuses. You can did you just see it focus? Okay, well it's focusing. But then I was under the impression that if you tie the tip and the sleeve together, it takes a photo, but it does not. You have to tie all three together. Ooh, and that's actually going to be weird. Because it did that. Do you see how it took like multiple? Did you hear it though? It went chick, chick, chick. It took 3 photos.
Was that not it focusing?
No, that was it taking 3 photos. So I'm wondering if I just go. Okay, wait, hold on. All right, I'm almost ready to wrap this up. All right, so there you go. So it's focusing. I kind of wish. I kind of hate this thing. Let's tie this like that. Okay, so I'll probably just have to play with it to find the exact. Okay, so I just have to find the amount of time that I set the pin high, because I don't want it to, and maybe I can change the settings in here for MCDC2. But yeah, I have no idea how this thing works, because it's like, how does it do what it does? Okay, how are you though? What have you been up to today? Really?
Yeah,
How's last night?
I told you I'm gonna look at photos of you
Oh,
today.
is that I thought you were joking.
All I've been doing is studying.
Oh, okay.
I have not done anything at all.
I love those photos. Man, you took some really good pictures. I really like the ones of when we were on that pier.
Oh, yeah.
My hair was kind of weird though.
Yeah. They gave you a weird hairline. It's because your hair is too long.
Yeah. All right,
You have to cut it.
I know. Actually, I don't think it's time to cut it yet. I kind of like it this length. Maybe I could trim it.
We're going on another trip. Don't you want some nice photos?
Okay, yeah, you're right. Oh, by the way, wait, hold
You
on.
just said you're